Hello, my dear friends. Today we are going to see our lecture number 12 in mechanics of solid subject. So today's topic is thin cylindrical and spherical vessels. Once again, I will repeat it: thin cylindrical and spherical vessels. So first of all, we should know what it means by thin cylindrical and spherical vessels. So the vessels such as boiler, compressed air receiver, etc., are of cylindrical and spherical in structure or in form. These vessels are generally used for storing fluids. If we talk about the term fluid means both liquid and gas. So these vessels are generally used for storing fluid under pressure, and the wall of such vessels are thin as compared to their diameter. So wall of these vessels will be very thin as compared to their diameter. So if the thickness of the wall of the cylinder vessel is less than 1 by 15 to 1 by 20 of its internal diameter, the cylindrical vessel is known as thin cylinder. Understand? The very important thing is the wall of cylindrical vessel is less than 1 by 20 to 1 by 15 to 1 by 20 of its internal diameter. Understand? And one more important thing, in case of thin cylinder, the stress distribution is assumed uniform over the thickness of the wall. Understand? So first of all, we will see what are the concepts which we have to cover throughout this. So these are our concepts. First one is what is thin cylinder, circumferential and hook stress, longitudinal stress, relation between circumferential hook stress and longitudinal stress, maximum stress, and thin spherical stress. Understand? So these are the topics which we have to cover throughout our lecture. So first we will see what is thin cylinder. As I discussed you earlier, what is thin cylinder? The thickness of the cell should be less than about 1 by 15 to 1 by 20 of the internal diameter. How much? 1 by 15 to 1 by 20. Mostly in solving numerical problem, we are taking 1 by 20 only. If they will give 1 by 50, 1 by 15, then we will take that one. Otherwise, we have to take 1 by 20. Understand? So, all cylindrical vessels subjected to fluid pressure are called as pressure vessels. Understand? And a thin pressure vessel or thin cylindrical cell is one for which metal thickness is very small as compared to its diameter. Same thing as I told you. That means the thickness of the wall of the cylindrical vessel should be less than 1 by 15 to 1 by 20 of its internal diameter. And one more important thing is, in thin cylinder, the stress distribution is assumed uniform over the thickness of the wall. So this is the diagram. This is the diagram of thin cylinder. Understand? See this properly. Okay, we will see our next slide. Circumferential or hoop stress. Circumferential or hoop stress. We will see. Actually, if you will consider a thin cylindrical vessel subjected to an internal fluid pressure, understand? Listen me carefully. Consider a thin cylindrical vessel subjected to an internal fluid pressure. The circumferential stress will be set up in the material of the cylinder. And how we will see? If it burst or burst into the two parts. Understand? That means the stresses which act in tangential direction to the perimeter or circumference of the cylinder are called as hoop stress or circumferential. Once again, I will repeat the definition. The stresses which act in tangential direction to the perimeter. That means it will act at circumference of the cylinder. That means perimeter. Understand? It's called as hoop stress or circumferential stress. So hoop stress or circumferential stress is denoted by sigma c. Sigma c is equal to P into G divided by 2 into G. Understand? Once again I will repeat the formula. Sigma c or circumferential stress, or you can say as hoop stress, is denoted by sigma c is equal to Pd divided by 2T, where T is equal to internal pressure of cylinder, L is equal to length of cylinder, sigma c is equal to circumferential stress or hoop stress, D is equal to internal diameter of the cell, T is equal to thickness of cell. Understand? So this is the definition and this is the formula for circumferential or hoop stress. If you will see longitudinal stress, which is denoted by sigma L, the stress developed in the wall of thin cylinder set in longitudinal direction due to internal fluid pressure are called as longitudinal stress. Understand? The stresses developed in the wall of a thin cylindrical set in a longitudinal direction, so the internal fluid pressure are called as longitudinal. As I told you, in the cylinder if we put fluid with a pressure, the stress developed in the wall of the cylinder in a longitudinal direction. If the stress is developed in longitudinal direction due to internal fluid pressure, then that type of stress is called as longitudinal. Understand? So longitudinal stress formula is sigma L. Sigma L is equal to Pd by 4. What is sigma L? Sigma L is a symbol to denote longitudinal stress. Sigma is symbol for denoting stress value. So if we are putting L here, that means longitudinal stress. If sigma is here and if we are putting C here, that is circumferential stress or hoop stress. Understand? So this is the formula. Sigma L is equal to Pd divided by 4T. Understand? If you will see in circumferential stress or hoop stress, the formula was sigma C is equal to Pd by 2T. Pd by 2T. But here the formula is Pd divided by 4, where P is equal to internal pressure of cylinder, L is equal to length of cell, sigma L is equal to longitudinal stress, D is equal to internal diameter of cell, T is equal to thickness of cell. Understand? I hope you must have understand this topic. Actually, I have arranged everything in a simple manner for you guys. Why? See, I have written the definition in only 2 lines and only one formula. So if you will remember this only one formula, then it will help you to solve numerical problem. Understand? To solve numerical problems, you must know the formula for circumferential stress, hoop stress, and longitudinal stress. Understand? Next we will see failure. Failure in circumferential stress, hoop stress, or failure in longitudinal stress. If the stress will be circumferential to the material, or if the stress will be longitudinal to the material, how it fails, how it bursts, or how it breaks. Understand? So see, if the stress will be circumferential or hoop stress at maximum, see it will fail like this. Due to the circumferential stress, failure. You see, I have written here failure due to circumferential or hoop stress. This is the diagram. So if they will ask in your exam to write about the circumferential stress, hoop stress or longitudinal stress, then what you have to do? You have to follow the definition with this diagram. Understand how actually it fails? Understand? So this is the failure due to longitudinal stress. This is the failure due to longitudinal stress. Understand? Now we will see relation between circumferential stress or hoop stress and longitudinal stress. Understand? Now we are going to see relation between circumferential or hoop stress and longitudinal stress. As we know that circumferential stress is denoted by sigma c equal to PD by 2Q, where P is equal to internal pressure of the fluid, D is equal to internal diameter of fluid, T is equal to thickness of the wall of the cylinder. Understand? And sigma c is equal to circumferential stress of two faces. Already we know this thing. Already we know this thing. It comes from circumferential stress on Hooke's stress formula. Understand? And second thing, this is the formula for longitudinal stress. Sigma L is equal to PD by 4T. Understand? Sigma L is equal to PD by 4T. PD by 4T. If you will see now, sigma L is equal to PD by 4T we know already. We can write PD by 4 as 1 by 2 into PD by 2T. We can write now. See, we have splitted PD by 4T into two terms. We have splitted PD divided by 4T into two terms. Two terms is we have arranged according to our needs, according to our use. Understand? So here what we have done, 1 by 2 we have taken out 1 by 2. So it will become PD divided by 2T here. So that it will multiply 1 by 2 with PD divided by 2T, then it will come as PD by 4T. Understand? See, these things you have to keep in your mind. If we are splitting one object or one term into two terms, then that two terms, if it combined, must should give the combination of the value of first term. So same things we have done here. We have splitted PD divided by 4T into two terms, half into PD by 2T. But when we combine these two terms, when we combine this term and this term, it will give same value, PD by 4T. So our value should be not altered. Understand? That is the main basic or main concept. So one more thing important thing here. Already we know PD by 2T. What is PD by 2T? It is the formula for Hooke's stress or circumferential stress. Understand? So instead of PD by 2T, what we can write? We can write directly sigma c. Why? Because sigma c is equal to PD by 2T. Am I right or wrong? Please focus here. Already I have written here. See, sigma c is equal to PD by 2T. So instead of PD by 2T, we have written sigma c. So our formula became like that. Half into sigma c. Our formula became like this. Half into sigma c instead of PD by 4T. So we can say that our longitudinal stress value will be sigma c by 2. Am I right or wrong? Our longitudinal stress value will be equal to sigma c by 2. Or if you will simplify further, if you will simplify further, it will become sigma c equal to 2 into sigma. That means circumferential stress or Hooke's stress is equal to the twice of longitudinal stress. Am I right or wrong? Am I clear? The circumferential stress is equal to twice of longitudinal stress. Sometimes in your exam they may ask, see the relation between circumferential stress or Hooke's stress and longitudinal stress. So you have to simply focus on two things. First of all, you have to remember this formula. Which formula? Circumferential stress formula. The second thing, you have to remember longitudinal stress formula. If you will remember these two formulas, then easily you can set or you can easily see the relation between circumferential stress and longitudinal stress. Because as I told you, PD by 2T is nothing but sigma c. So we have to here. So finally we got the equation as sigma c is equal to 2 into sigma s. That means circumferential stress is equal to twice of longitudinal. So sometimes in a numerical problem they may ask this relation. So you should always remember this thing. Understand? Now we will see our next. Now we are going to see what is maximum stress. Understand? Now we are going to see what is the maximum stress. How it occurs, understand? So, I have written here, circumferential stress is the maximum compared to longitudinal stress. As I told you, if you will compare some circumferential stress or longitudinal stress, what is circumferential stress? Circumferential stress is twice as compared to longitudinal stress. So, circumferential stress is maximum compared to longitudinal stress. That means maximum stress value is circumferential stress value is equal to PD by 2. Am I right or wrong? Circumferential stress value is the maximum stress as compared to longitudinal stress. So maximum stress will be circumferential stress only, na? So maximum stress. So maximum stress will be equal to circumferential stress, and we know the formula for circumferential output stress. That is PD divided by 2T, where P is equal to internal pressure of fluid, D is equal to internal diameter of cylinder, and T is equal to thickness of the wall of the cylinder. Understand? So, if they will ask to find out the maximum stress, then what we will find? Circumferential stress. Because circumferential stress is the maximum stress. Understand? Now we are going to see thin spherical shape. Thin spherical shape. Since a sphere is a symmetrical body, a stress generated in both the direction are same. A sphere is a symmetrical body. A sphere is a symmetrical body. So a stress generated in both directions is the same. So sigma s will be equal to, stress will be equal to circumferential stress, and circumferential stress will be equal to longitudinal stress, and formula will be 4D by PD by 4T. PD by 4T. Remember this formula. We will use in solving numerical problems. Now we will see our summary, what we have learned throughout this lecture. First of all, what we have learned, what is thin cylinder. Then we have learned what is circumferential or hoop stress. Then we have seen longitudinal stress. Then relation between circumferential and hoop stress and longitudinal stress. Then finally maximum stress and thin spherical stress. What is thin cylinder? What is thin cylinder? If the thickness of the wall of the cylinder vessel is less than 1 by 15 to 1 by 20 of its internal diameter. That is the main thing you have to always keep in your mind. Because whenever we will solve a major problem, only these terms will be in our use. We will not see the definition of this cylinder. But we have to remember this thing. It should be comes between 1 by 15 to 1 by 20. Understand? Then what is the circumferential stress or hoop stress? What is circumferential stress? Circumferential stress formula is PD by 2T. PD by 2T. Understand? Sigma C is equal to PD by 2T. And what is the longitudinal stress? Longitudinal stress formula is PD by 4T. Always remember PD by 4T. Understand? And if you will see relation between circumferential stress or hoop stress and longitudinal stress, then what we got? Sigma C, circumferential stress, is the twice of longitudinal stress. Understand? So circumferential stress value will be the maximum. Then finally we have seen what is maximum stress. So what we have seen, circumferential stress is the maximum stress, because as compared to longitudinal stress, circumferential stress is twice. So maximum stress, if we will ask the formula of maximum stress, what will like? We will like circumferential. And finally we have seen thin spherical shape. Understand? If you want to know or if you want to gather more information about the following topic, then you can refer these books also. First book is the Strength of Material book by Dr. R.K. Bansal. Publication name is Dhanpal by Answer. And second book you can refer is Mechanics of Solid by R.S. Smith. Understand? Western publication. If you will refer these two books, then you can get a brief idea of particular topic to solve numerical problem also, or to gather knowledge in an effective manner also. So if you want to gather information or if you want to know more about this following topic, then you can refer these two books. Understand? I hope you all must have understand this topic in a best and effective manner, because I have given everything to you in a very easy manner. I don't think anything I have given is not understandable to you. Understand? So this was our lecture 12 about the topic thin cylindrical and spherical vessels in mechanics of solid. I hope you all must have understand all the topics in an effective and good manner. Thank you. Have a nice day.